Today's lesson involves the multiplication of radical expressions. In the first part, we're going to multiply radical expressions in a very simple way. For example, the square root of 3 times the square root of 8 times the square root of 10. In this situation, as you can see, what we have inside is natural numbers, and what we're going to do is multiply them, what is inside the root with what is inside the other roots. Okay, coefficients go with coefficients, radicands go with radicands. So in here, this multiplication will end up being a big square root, 3 times 8 times 10. Therefore, the final multiplication will be 240. Now, once we have the 240 correctly identified, we need to proceed to check how we are going to simplify that 240. One of the suggested methods is the prime factorization process, which is very simple. We start by looking for the prime factorization of 240. In this case, divisible by 2 because it ends in 0. And we continue doing this process until the 2 cannot be used. So we divide by 2 again, we have a 60. We have a 2 again, we have a 30. We divide by 2 again, we have a 15. Then we divide by 3, we have a 5, 5, and 1. So once we stop the process, we discover that we can create two pairs. And the pairs are going to be these ones. 2 times 2 and 2 times 2. 3 and 5 are single, so we can leave them alone inside a root doing a multiplication. So this will become the square root of 2 squared times 2 squared times the square root of 15. I'm going to simplify these two numbers that are completely alone as one root. Then in here, what we apply is the canceling rule for the radicals. Okay, this radical cancels the root and the square, and the radical cancels this square in here. So outside the root, we have these elements, and inside the root, we have 15. Therefore, what we have is 4 square root of 15. This answer is written in what we call simplest radical form. And we come to this form when the radical inside the root cannot be simplified anymore. So once we understood this process, we analyze prime factorization and we apply prime factorization to do the process. This is our final answer. So now let's wait for the second problem. On the second problem, we're going to be using the distributive property as a tool for simplifying. Then we have exercise number 2 will be the square root of 5 times 3 square root of 2 minus the square root of 20. Now, as you can see, we have a radical expression inside the parentheses, and we have another radical expression outside the parentheses. So what we're going to do is apply the distributive property and multiply this radical in this way. Remembering that radical with radical, radical with radical. So in this case, final answer in here will be 3 square root of 10 minus the square root of 20 times 5, which is 100. Okay, we proceed to do a simplification of this. 3 square root of 10 stays exactly as it is because we cannot do anything with the 10. But the square root of 100 is a perfect square, and that value is equal to 10. Therefore, this will be my final answer in simplest radical form. And also remembering that these two numbers cannot be combined because one contains a radical and the other one doesn't have it. A third example will be when we have, for example, this situation in here. Square root of 20 times square root of 20. If we check, what we are going to multiply is two square roots that have the same elements, 20 and 20. So I can go and multiply 20 by 20 and the answer will be 400. But in this case, what I want to do is use a property that we know from the radical expressions. 20 times 20 is equivalent to 20 to the second power. And in this case, the cancelling of the square with the root will give me as a final answer 20. So in here we are using a different element to cancel the operation, right? Let's wait for the second part of the video in order to explain other types of multiplications. Okay, continuing with the multiplication of radical expressions, now we're going to have slightly more complex operations. What we need to do is check always that we're going to multiply radicals with radicals every time that we're doing this. So in this case, we're going to have 4 times the square root of 2 times 8, which will give me 16, minus 3 times the square root of 20. Now in this case, what we need to check is if the expressions that are inside the radicals can be simplified. So I'm going to use, in this case, 16 is a perfect square. So we know that 4 and the square root of 16 is another 4. Minus 3 times. What I'm going to do with number 20 is that I'm going to check for perfect squares that are close to 20. One of them is 16, so that means I can use 4 times 5. And in here, that 4 has a perfect square root. So we can take it out, and then we just leave the square root of 5 inside. So in here, what we're going to have is 16 minus 3 times 2 multiplied by the square root of 5. And finally, we're going to have 6 minus 16, minus 6 square root of 5. Again, checking that this answer is written in simplest radical form. Why? Because the square root of 5 cannot be simplified and the expressions cannot be combined. Therefore, there we have an answer. So in this case, that is my simplest radical form for this expression. Now we're going to continue with another exercise in which we're going to use familiar patterns from the polynomials. What do I mean by familiar patterns? Patterns like the squares of binomials, by sum and difference, perfect square trinomials, etc., etc. So let's see problem number 5. Problem number 5 involves this. 2 square root of 3 plus 3 square root of 2 and this to the second power. So if you see here, what we have is a and b to the second power. That means the square of a binomial. And the square of a binomial can be simplified by using this pattern. A squared plus 2ab plus b squared. Identifying that this element will be a and this element will be letter b. So let's proceed with the problem. Let's replace the information. 2 square root of 3 to the second power plus 2 times 2 square root of 3 times 3 square root of 2 plus parentheses 3 square root of 2 to the second power. Once we have replaced the information, let's proceed and apply the squares and the square roots in here. So in here, 2 to the second power is 4. The square root of 3 to the second power becomes 3. the roots cancel. In here, we're going to multiply all the coefficients, 2 times 2 times 3, which becomes 12. And inside the radicals, we have 3 and 2, which is 6. And finally, we have 3 to the second power, which is 9, multiplied by square root of 2 to the second power, cancels the root, and the answer becomes 2. And in here, we just proceed to simplify what is left of the expression. Analyzing that, some of the radicals disappear, and then they become natural numbers. This is 12 plus 12 square root of 6 plus 18. And finally, the last part of the expression will be 12 plus 18, which is 30, plus 12 square root of 6. Again, we have an expression in simplest radical form, which is totally unfactorable anymore because the square root of 6 do not have a perfect square. Then this is what we call the simplest radical form of this expression, and if you remember, we applied the square of binomial span. Finally, we're going to be using one example more, which is going to be the sum and difference pattern. Now, what is the importance of the sum and difference pattern? That we're going to be using it also in division a lot. So, let's pay attention to this example. 5 square root of 6 minus 3 and 5 square root of 6 plus 3. If you see, we have a sum and difference pattern. Okay, identifying A and identifying B. Let's remember that this pattern is solved by applying this format, which is the difference of two squares. Okay, very important. Remember, difference of two perfect squares. So let's replace the information that we have in here. A is 5 square root of 6 to the second power minus 3, which is also to the second power. And then we proceed to simplify the roots and the powers. 5 to the second power becomes 25. The square root of 6 to the second power becomes 6. Remember, the roots gets cancelled. And 3 to the second power becomes 9. Here, what we have is 150 minus 9. And finally, the final answer, which is 141. As I told you, one of the important parts of the sum and difference pattern is that the final answer will always be an integer, okay? Canceling automatically all the roots that we have in here. Okay? On the next part of the class, we're going to talk about division.